Okay, so next unit, I know we're not really talking like unit and large tests, but so far we've done our unit on basic operations where we use our calculator. Okay, and then we just finished our unit over solving equations and inequalities. So the next unit that we're going to look at deals with functions and relations. Okay, and I even kind of hesitate to write it this way because when we talk about functions and relations, it makes it sound like we're talking about two different things. And that's not really the case at all. Okay, functions and relations are sort of a category within a category. Okay, so milk, if you go to the grocery store and you buy milk, what types of milk can you buy? 1%, 2%, chocolate milk, whatever. Okay, so milk would be the big category. 2% milk would be a specific type. Okay, and that's what we're talking about. Relations would be the big category. And we're going to sort of narrow down as we get to the end of class today into the more specific type of relations that we call functions. Okay, when we are talking about relations, the largest piece that we need to understand is that there's lots of ways to represent them. So all of these representations that we're going to look at are fair game for both relations and functions, since functions are a specific type. Okay, and this is the piece that I often see students struggle with the most. We talk about it, we say, hey, you can do this, and it's like, oh, check, I learned it, I tested over it, I'm never going to think about it again. And being able to recognize that something has multiple representations is a key way to dealing with some of the more complex math as you move forward. Okay, so if George has $10 and I have two $5, who has more money? We both have the same thing, right? We're talking about the same thing, but we're representing it with different words. Okay, and that's exactly what we're going to be looking at. So there are different ways that we can represent them. Option one is that we can represent them as what we call ordered pairs. Right? Ordered pairs are when we're writing something with an x value and a y value in parentheses, right? We have an x coordinate and we have a y coordinate. So this relation that we're talking about could represent something that we might commonly hear about. So for example, I know you guys are sort of reaching the end, but you're still growing. Right? When you go to your doctor, right, and they take your height and your weight, and then they graph those and plot those to see your growth trend over the years. Right? That's a pretty common way that we talk about something as being an ordered pair. But it doesn't even have to be a number. It could be your favorite color, comma, how many cookies you ate last week. Right? It can be totally ridiculous. It doesn't have to be something that we think is always logical or makes sense. We can represent relations as a table. So I think this must be a middle school thing. I hadn't heard it until recently. And in the last several years, I've heard students no longer saying table, but saying a T-chart. Have we heard that? That's a table. I'm not really sure where that T-chart word is coming from, but it's a table. Okay? When we're making a table, our X values are on the left. Our Y values are on the right. We can represent them as a graph. Okay, so a graph is when we are taking some info that we know from a relation and we are putting it on the coordinate plane. So we are definitely not reteaching the coordinate plane. If you need extra practice with the coordinate plane, Alex will supplement that info. Okay, but I am going to give you a few quick reminders. Like, what do we call our horizontal axis? Lily? This is the x, which makes this one the y. What is this point right here in the middle? The origin, right? The origin is our point 0, 0. Right, when we're plotting things in the coordinate plane, right, if it's like 4, 7, it tells us how many to go right or left and how many to go up or down. Okay, we'll look at that a little bit more specifically in doing some practice with that. The last way that we can represent is called a mapping. Okay, these first three you should be like, yes, I've heard of ordered pairs, I've heard of tables, and I've heard of the coordinate plane before. Okay, the last one, the mapping, is sort of the weird one. Okay, and it's kind of like connect the dots. So we tend to sort of draw ovals, but there's nothing that says it has to be an oval. Okay, it could be a square, it could be nothing, whatever. But we're going to list the x values on the left, and we're going to list the y values on the right, and we're sort of going to connect the dots. So the x values go over here, and the y values go over here. Okay, but here's the key. When we list our x values and our y values, it gets some very specific rules as to how we list them. Okay, so when we list them, we have to list with no, for both of them. This counts for both the x and the y. We're going to list with no repeats, and we're going to list in numerical order. What does in numerical order mean? Least to greatest, right? Smaller to larger. Sorry, I got that kind of low. Okay, so all four of these things are representations of the exact same info. They look different, but they tell us the exact same info. Okay, so let's say I'm given some info. I have no idea what it's going to be. And it's given to me in ordered pairs. And so I'm going to be told that I have some info of 8, 6, -4, 2, 3, 7, and 0, 2. This is my grouping of info. Okay, maybe the first number represents someone's favorite number, and the second number represents how many fish they have. I don't know, whatever. It can be totally ridiculous, doesn't matter. Once we say that we have a complete set of info, we want all of that to be the stuff together. In math, we represent that that's the set that goes together with braces. Okay, so there's sort of those squiggly parentheses. You do not have to worry about writing them too perfectly that often because in ALEKS, you'll just be able to type it. Okay, but do not replace a brace with a parenthesis. They don't mean the same thing. Okay, parentheses tell us things like multiplication when we're looking at order of operations. Okay, they tell us things like here, this X and Y go together. Braces tell us here we have a complete set. We can then take that info and we can turn it into any of the other representations that we were talking about. So the next option that we said we could use was a table. So I can take this info, this data of whatever, and I can turn this into a table. Okay, and I can do that by literally just taking each ordered pair and vertically stacking them up. So my first ordered pair has 8 as an X value and 6 as a Y value. Sometimes we will see tables in numerical order for the X values, but it is not a hard rule. It happens a lot when we do some other things. So don't try and force it unless you have to. Okay, it's totally fine that we just go straight across here. So our next one is -4, 2. Then we have 3, 7. Then we have 0, 2. Now, here's why I say often we will see the X values in numerical order, because often a table is used to represent data in a more reasonable way to process it. Okay, and so it makes sense to see least to greatest so we could have things sort of grouped together, but it's just not a requirement. Okay. Now, likewise, if we were given this table first, we should be able to just pull out the ordered pair 8, 6, -4, 2, 3, 7. We okay there? Okay, the second representation that we said we could do was we could make a graph. Okay, here is where I hate to assume. Being able to plot ordered pairs in the coordinate plane is something that you start learning about in 4th grade. We should be able to plot points. However, if you say I'm clearly not doing this correctly, you need to find time to come and work with me on an Alex day. Okay, we have to be able to plot points. So if I want to plot the point 8, 6, right? This says go on my x-axis to 8, and then go on my y-axis to 6. Make a point. Okay, in reverse, you should be able to be given this point, and you should be able to name it. Right? You should be able to look at that point and go, oh look, it's right 8 up 6, so that's the ordered pair 8, 6. Oh, since that's the ordered pair 8, 6, I should be able to put that in a table. Okay. -4, 2, so we're going to go left 4, up 2. How about 3, 7? What are we going to do to graph 3, 7? Over 3. Up 7. Zero, 2 says don't go anywhere right and left, but then go up 2. Hopefully those 3 things you're just like, yes, this makes sense. I've seen this before. I can do that. That's fine. Okay, the mapping again might be the one that's a little bit weird. So for the mapping, we're going to have our x values on the left and our y values on the right. So if we look up here, our x values, well, I guess we put them in the table, so we can put them right here. We need to list these in numerical order. So what's our smallest x value? -4, then what? 0, then 8. Perfect. Okay, so now we're going to do our y values. What's our smallest one? 2, then what? 6, then? How come I'm not listing the 2 twice? I said no repeats, right? So we only write it down one time. Okay, then this is just connect the dots. So I'm going to draw a line between 8 and 6. An arrow, a line, you can see it either way. I'm going to draw a line between -4 and 2. I'm going to draw a line between 3 and 7. And I'm going to draw a line between 0 and 2. Okay? Are we okay on those? We can talk about the inverse of a relation. Okay, an inverse has a fancy definition, but all you're really going to do is switch the x and y. So if it was 1, 2, you're going to swap it to a 2, 1. Those are the points you should not miss when you take your assessment with this. So if I say, okay, class, write the inverse of this relation, what would you turn 8, 6 into? 6, 8. 3, 1 would become 1, 3. -2, 7 would become
7.
So that's a pretty easy one. And realistically, class, because you can use your notebook, there are a lot of new terms in here, but none of them are difficult. So if you keep your notebook, these are the points you shouldn't be missing, because you just need to look and see what it is. Right? If you're like, oh, I forget what I can write in a mapping, right? You just look. Oh, yeah, X is on the left, Y is on the right, no repeats in numerical order. Question? Is that a question? No. Okay, we can also talk about the domain and the range. Okay, the domain is going to be the x values. The range is going to be the y values. The problem is that this isn't a representation, because as soon as you pull it out of the info, you can't go backwards. You can't go from a table to listing the domain and range, and then go from the domain and range back to the table. This is a one-way path, which means it's not a new representation. It just tells us info. Okay, when we list the domain and the range, both of them get the same qualifications. That we're going to list no repeats. We're going to list in numerical order. And they're going to go in braces. So usually about this point, my students are like, oh my gosh, notes are so boring today, because there is a lot of vocab. Okay, but like I said, these are those sort of simple vocab pieces that if you have them in your notebook, it'll be easy to get when you take your quiz. So let's say I have 2 comma 5, 1 comma negative 6, negative 2 comma 5. Say, okay, here's my info. Tell me what the domain is. Okay, for the domain, you're going to list the x values. Are the x values first or are the x values second? First, right? So we're going to take the first number. We're going to list it in numerical order. So what's the smallest number? Negative 2. Then 1. Then 2. And here's the kicker, and it frustrates my students to no end. It has to be in braces. I will count it wrong. Alex will count it wrong. It is wrong without braces. Oh, that was a terrible brace, but. Okay, it has to be in braces. You are representing a set of info. It goes in braces. Okay, so the same thing for the range. Now we're going to list the y values. Do those come first or do those come second? Second. So what's our smallest? Then nothing, right? Because we don't list any repeats. All of this info, okay, works for any relation that ever exists. Okay, but sometimes that relation is really special. It still gets all of these properties, okay, but it has a unique fact that means it's a special type of relation that we call a function. A function is a relation. It's not different than one. It is a relation.
Sorry to interrupt you. Can I please have Diego Rios to the front office, please?
Does he need to bring his items with him?
No.
Yep, I will send him.
Thank you.
Do you think I should look? Because it's a meeting with my parents and I mean.
You can if you want to. Okay, so it is a relation, but it has a special fact that says the x value can't repeat. Which means we don't want to see a duplicate of the x value. I can't use the same number more than one time. Okay, so our big objective today is going to be to decide if I'm given info. So if I have a bunch of relations in a hat and I pull out a card, we want to decide, is it a relation or is it not a relation? Is it a function that's a relation or is it not a function that's a relation? Okay, so let's look at some options here. We know it's a relation because it's written in a table, and every relation can be written in a table. But now we want to decide, is it a special type of relation? Is it that special type that we call a function? And we decide by looking at the x values. So we are going to look at the x values only and ignore the y's. These don't matter. Do the x values repeat? No. So is this a function? Yes, that's a really confusing question because it's backwards. Do the x values repeat? No. So is it a function? Yes. So yes, this is a function. How about this one? Is this one a function? Okay, so Lily, you're shaking your head no. Why not? Because right here, looking at the x values only, y values do not count. Do we see a repeat? Yes. So is it a function? No. We're almost done with notes. I know it's a long one today. I know. This is a tricky one. Okay, and the reason why it's tricky is because we can't list any repeats, which means we will not see a number more than one time. Right? I can't see a duplicate number over here. Now again, this side doesn't matter. It's only this side that matters. So if I can't see a duplicate number, I'm actually looking for something that has 2 lines coming from it. So how many lines are coming from 3? 1, which means it's used 1 time. How many lines are coming from 4? 1, which means it's used 1 time. How many lines are coming from 5? 1, which means it's used 1 time. So do any of those repeat? Nope. So is it a function? Yup. Last one. If we're looking at a graph, we don't see numbers at all. So, I mean, I guess you could try and write down every point on that graph. You'd be writing down forever, so that would be really goofy. So instead, what we do is we try and draw a vertical line that will touch the graph twice. So a vertical line is a line that goes up and down. We want to see if we can find a vertical line that will touch the graph twice. Well, that touches once. That touches once. Once, 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 once. Is there anywhere I'm going to be able to draw a vertical line that touches this twice? No. So vertical lines only touch once. So this is a function. Okay, touching it twice would be the repeat in the x value. Now this one you could write down in a different representation. So you could turn this into a table or a mapping or order pairs and look. Okay, but if we look, is there anywhere we can draw a vertical line that is going to touch this twice? Right? Right here. Touched it once. Touched it twice. So did this touch twice? Yes. So is it a function? No. This is not a function.